Module 3, Lesson 16, we're looking at symmetry in the coordinate plane. And symmetry is when there are two sides that are the same. So in the opening exercise, we're asked to give an example of two opposite numbers and describe where the numbers lie on the number line. Then tell how opposite numbers are similar and how they are different. So two opposite numbers, let's just say 2 and -2 are opposite. And 2 is 2 units to the right of 0, while -2 is 2 units to the left of 0. So we could then say that their similarities are they're both 2 units from 0. And the difference is in their direction from 0. So now we're going to extend our understanding of opposite numbers to the coordinate plane. We're going to start by locating and labeling 2 points on the coordinate plane. The first point is 3, 4. So across 3, up 4. And the second point is -3, 4. So 3 in the negative direction and 4. Pay attention to the absolute values of your coordinates and where the points lie in reference to each axis. You should notice, for example, that these 2 points, and let's write them so we know what we're looking at, 3, -4, and 3, 4, have the same absolute values, and the only thing that changes is the y-coordinate. You should also notice then that they are a reflection of each other across the y-axis. This could be considered like a mirror, and this is a reflection. Now, let's graph another point, -3, -4. And in looking at that point, we can see that it is reflecting from our second point, it is reflecting over the x-axis. See, like a mirror. Or we could also say that it is reflecting across the origin from our first point. See what we're saying? I admit when we started there was an error. I corrected the error. And so our first point would have been -3, 4. That was my correction. The second point we graphed was 3, 4. Then we graphed -3, -4. And finally I graphed 3, -4. 3, -4 is reflected across the x-axis from 3, 4. Then complete the table on the next page based on your observations from graphing these points. So in completing our table, please make sure you have all the details and then in our exercise, we will practice. So if we're starting with point S, which is at 5, 3, that point reflected across the x-axis would be point M, whose coordinates are 5, negative 3. Reflected across the y-axis would be point L, whose coordinates are negative 5, 3. Reflected first across the x and then across the y-axis would be point A, whose coordinates are negative 5, negative 3. And then reflected first across the y-axis and then across the x-axis would be exactly the same point, that is point A, whose coordinates are negative 5, negative 3. And we'll do the same thing for the second point. Negative 2, 4. Which we don't really have to graph in order to be able to do this. If we're reflecting across the x-axis, those coordinates would be negative 2, negative 4. Across the y-axis would be positive 2, 4. Across the x and then y-axis would be 2, negative 4. And of course the same. Our next point, 3, negative 2, across the x-axis. Hopefully you're noticing the pattern. Would be 3, 2. Across the y-axis would be negative 3, negative 2. Across first the x and then the y would be negative 3, 2, taking the opposite of both. And the same thing would be true for reflecting across the y and then the x. And our final number, and by now you should be pretty good at the rules. If I'm reflecting across the x-axis, I'm going to do the opposite for my y-coordinate. So that would be negative 1, 5. If I'm reflecting across the y, I'm going to take the opposite of the x-coordinate. So that'll be 1, negative 5. And if I'm reflecting across both, I'm going to change both signs. and that will be 1, 5, which is also the case if we change the order. It still ends up in the same spot. So then looking at it, when the coordinates of 2 points, x, y, and negative x, y, what line of symmetry do the points share? Well, they would be reflecting across the y-axis. And when the coordinates are x, y, and x negative y, they would be reflecting across the x-axis.